So we'll be taking some basic acids and then we try to learn how we can name these acids. And then I'm talking about naming of acids, how we can use IUPAC nomenclature in naming the acids. Okay, so if you want to get the best of this tutorial, I want you to watch the video to the end, because there's a secret or there's a key to naming this particular acid, and if you do not watch the video to the end, you might miss that key. So let's start by taking this acid and see how we can name it. First one is this HNO2. So to name this acid, all that you need to do first is to find the oxidation number of the central atom, which is N here. Okay, so to do so, you know that hydrogen is having a fixed oxidation number of +1, and then oxygen is having a fixed oxidation number of -2. So all that you need to do is finding the oxidation number of the central atom, which is nitrogen. That will help you to name the acid. And then, so this is how we do it. So because hydrogen is having a fixed oxidation number of 1, we write 1 here. And then N, that's the nitrogen, we are calculating for the oxidation number of nitrogen. So we replace it by a variable, let's say X. So say plus X here. And then because oxygen is having a fixed oxidation on -2, right, -2 here, and then we multiply by the subscript 2 here, so times 2. And then because this is a compound, and then this compound is not having any charge, so we say that the total oxidation number of this compound is 0. So the rule of naming compounds or giving the IUPAC name to the compound is that when we add the individual oxidation number here in a compound, that's when we add nitrogen, hydrogen, and then oxygen together, we should get the total oxidation number of the compound. And because the total oxidation number of this compound is 0, we equate everything to be equal to 0 here. So at this point, we just need to simplify our expression, and by simplifying, we can get 1 plus X, and -2 times 2 give us -4, so -4 here, and it's equal to 0, like this. So at this point, we just need to make or have to make as the subject or group like terms. And in grouping like terms, we can just put it this way: X -4 plus 1 equal to 0. And then finally our X, because -4 plus 1 will give a -3, so I have -3 here, is equal to 0. And finally X is equal to +3. And then the +3 is the oxidation number of the nitrogen. So by giving the name of the compound, we can now give the name to the compound because we have the oxidation number of the central atom, which is nitrogen. So the name of the compound cannot be, because we consider the number of the oxygen atom here, and that will give us the name. So can say that because the oxygen number of oxygen here is 2, so we say that diazo, and then the nitrogen will change to nitrate. So the name now becomes diazo nitrate. And then you bring the oxidation number which is 3. So diazonitrate 3, and you put it in a bracket like this, acid, and then you just bring the name. So now the name of this compound is diazonitrate 3 acid. So let's take the next example and see how we can also solve it. The second example is H2SO4. So with this, we also use the same principle. Here we calculate for the oxidation number of the central atom, which is the sulfur here. So hydrogen is having a first oxidation number of +1. So because of this subscript 2, we multiply the 2 by 1, so have 1 times 2. And then because we want the oxidation number for sulfur, we represent it by X. So sulfur is represented by X here because we don't know its oxidation number and we are calculating for. And then oxygen is having a fixed oxidation number of -2. So we say -2 here, we multiply it by the subscript 4. And then we should quit everything, because when we sum up the individual oxidation numbers of the element forming the compound hydrogen sulfate, it means that it should be equal to the total oxidation number of the compound. And this is a neutral compound because there's no charge attached to the compound. So we say the oxidation number of this compound is 0. So we equate this one to 0 like this. Okay, so here all that we need to do to simplify our expression, and to simplify it, we can just, let's continue from this half, and it's going to be like this. 1 times 2 is 2. So write a 2 here, plus x here, and then -2 times 4 will give us -8. So have -8 here, and is equal to 0. Okay, so let's simplify this expression, or let's group like terms. By grouping like terms, I mean that let's put the one with that variable together and the one with the variable together. So it's going to be like this. +2 minus 8 will give us -6, plus x is equal to 0. So in simplification, our x now be equal to +6, because the -6 we cross the equal sign and become positive. So now the oxidation number for sulfur is now +6. So how do we name it, or how do we give its name? By giving the name, we consider the number of the oxygen atoms here. The oxygen atoms here are 4, so the name starts from tetraoxo. So you can say tetraoxo, or you can start from the first atom, which is hydrogen, and say hydrogen tetraoxo. Okay, so when I say hydrogen tetraoxo and I bring the name, I shouldn't add acid too. So it means that the name has been mentioned already. So we can give this compound 2 names, which will be correct. So we can say tetraoxo sulfate 6. Okay, tetraoxo sulfate 6 acid is correct. And you can also say hydrogen tetraoxo sulfate 6, and this one you not add acid to it, because you've defined, or you brought the hydrogen, and the hydrogen make this compound an acid. Okay, so this is how we name the oxo-acid. Let's take another example and also see how we can name it. Okay, let's take this example too and see how we can also name this type of acid. And this is going to be the third example, and it's written like this: can call hydrogen carbonate. All right, so to name this one, always we calculate the oxidation number of the central atom, and the central atom here is carbon. So we know that hydrogen is having an oxidation number which is 1 + 1, and oxygen is also having a fixed oxidation number of -2 in so many compounds except in hydrogen peroxide and then superoxide. In hydrogen peroxide is -1. So in most of the compound, the oxidation number of oxygen is always -2. So here in this compound too, the oxidation number here of oxygen is -2. So to find the oxidation number of the central atom will now become easy because we now know the oxidation number of oxygen and hydrogen. So the hydrogen have a fixed oxidation number of 1 + 1. So multiply by subscript here. So you're going to be 1 multiplied by 2 plus x. X means that the S is representing the C here. So it's like we are calculating for the oxidation number of C, and then we replace by X here. Okay, and then because oxygen is having a fixed oxidation number of -2 in many compounds, so mean that -2 is here, and then we multiply by the subscript 3 here. So times 3 should be equal to. So because we are dealing with a neutral compound, it means that the total oxidation number of the compound is equal to 0. So when we sum the individual oxidation number of the elements in the compound should be equal to the oxidation number of the compound, which is 0. So here we have 0 here. So 1 times 2 will give us 2 plus x minus -2 times 6 will give 3 will give us -6. Okay, like this should be equal to 0. At this point, we try to group it like terms. So we have +2 here, -6 here, plus x is equal to 0, and then we have -4 here because +2 minus 6 will give us -4. So plus x equal to 0 here. So with our calculation, we can see that if we make x the subject, our x will now be equal to +4. So to name this compound, you can say that the compound is, whether you can name it two ways. We can start with from the hydrogen triosocarbonate 4, or can say triosocarbonate 4 acid, and both are correct. So let's start by saying this. Let's name it this way. Because it's an acid, and then the name of the compound, we start from first knowing the total number of oxygen atoms here. So the total number of oxygen atoms here are 3, so we now call it trioso. Meaning trioso means that the number of the oxygen atoms are 3. So triosocarbonate. Triosocarbonate, and then carbonate what? The carbonate means that is the carbon that we calculated for its oxidation number. So carbonate 4, and the 4 we put it in bracket like this. Triosocarbonate 4 acid, or you can say that it's hydrogen triosocarbonate 4, and it's so correct. So let's take another example on this one, and that one's going to be the last example. And then I know that by this last example, everybody will be able to name oxo-acids. So let's take it, and it's like this. H2SO3. Say 3. Okay, so this is the compound, it's H2SO3. So with these two, all that we need to do is we find the oxidation number of the central atom sulfur here. Okay, so I've said it earlier on that the hydrogen having phase oxidation number +1, and then oxygen is having phase oxidation number of -2 in most compounds. So with this one, we just write the oxidation number of hydrogen here, which is 1, and multiply by the substrate, which is 2 here. So 1 times 2 give us 2. So I'm going to write 2 here. Plus the oxidation number of sulfur, we don't know, so we replace by a variable x minus 2, meaning 2 is the oxidation number of the oxygen here, times the subscript, that is 3 here, should be equal to, this is very important, we should know the total oxidation number of the compound. And then in my first tutorial on naming of oxo-acid, oxo-anions, and then how to even name compounds in general, I stated the rule that when you have neutral compound, its oxidation number is equal to 0. So because this neutral compound, the oxidation number is equal to 0, so just bring its total oxidation number here 0. So here, what do? We simplify this, and then by simplifying it, we have 2 plus x minus 2 times 3 give us -6 is equal to 0, like this. So let's group like terms and see. +2 minus 6 will give us -4. So we have -4 here plus x equal to 0. And then by grouping like terms, my x is now equal to +4, like this. So how do we name this compound? It's also an acid. And then I said that you can name it two ways. You can start by saying hydrogen trioxo sulfate 4, or you can say trioxo sulfate 4 acid. You are correct. So let's try to name this compound by saying that it's hydrogen, okay, trioxo sulfate. Trioxo sulfate. The sulfate is, when we are naming it, we change the name of the sulfur to sulfate. So hydrogen trioxo sulfate 4, and then you put a 4 here. Hydrogen trioxo sulfate 4. So you don't have to bring hydrogen trioxo sulfate 4 acid because of the hydrogen that you brought here. So for you to bring the acid, you eliminate the hydrogen and start with trioxo sulfate 4 acid. So we can say this one, or can write another one here, be trioxo sulfate 4 acid, and both are correct. So I know this tutorial has been of good help to you. So for more tutorials like this in chemistry, physics, and mathematics, subscribe to my channel, and then we meet on next tutorial. Thank you.